Okay, here we go. A little help for the math posse that I've got. Let's talk today about finding the equation for horizontal pieces, for vertical pieces, and then for slanted pieces. So first, let me draw a horizontal piece on here. Here's a horizontal line. We're going to try and write the equation for this particular horizontal. So again, we have a horizontal. Our equation for this horizontal, notice that everywhere along this line, the y values have the same total. They're all 4. So if we look here, y is 4, here y is 4, everywhere y is 4. So our equation is going to start out y equals 4. Now, the domain part, we are using from here to here on the x-axis. Our far left point is above -3. Our far right point is above 5. So our domain is going to be -3 is less than or equal to x is less than or equal to 5. These two things are what we would need to see on your paper to describe a horizontal segment. Y equals what number? In this case 4, because we're going across at 4. And then our domain from our left endpoint and from our right endpoint, giving us 3 and 5. Moving on to vertical pieces. Let's take a vertical piece like this particular vertical piece. Now notice along this vertical piece, everywhere along this vertical piece, the x has the same value. Here x is 2, here x is 2, here x has a 2 value. So our vertical equations are going to be x equals some number. In this case, it's the number 2, because every point on that vertical line has an x value of 2. To find our domain here, we're going to use our upper and our lower endpoints. Here, the lowest we go is 2. The highest we go is 6. So we're going to start at 2, less than or equal to, less than or equal to, and 6. And this time, in between, instead of x, we're going to put y, because our y is changing, because we're moving up and down. So our form for a vertical line, x equals 2, and then our domain would be 2 is less than or equal to y is less than or equal to 6. So horizontal and vertical, the equations are simple. It's either y equals a number or x equals a number. And then our domain would go from our left and right endpoints or our lower and upper endpoints. For our oblique or slanted lines, on our paper we've taken the time to draw on a line in your drawing. So here's an oblique line for me. Passes through this point, and this point. The pen was a little off, so it doesn't look too great. But for me to find the equation for this slanted line, I need two things. I need a slope and I need a point. To calculate our slope, we pick 2 points we can read off. Count up how high we went, 1. Count up how far over we moved, 2. Our slope is rise over run, so we went up 1, we went right 2. In this problem, my slope is 1/2. I could use any 2 points. I could use this point to here, and my slope is still 1/2. Next, pick a point. Now let's take this point right here. Its ordered pair is 1, 3. So 1, 3 is that ordered pair. Read off the coordinates. Now we're going to take these two pieces of information and we're going to plug them into y minus y1 equals m times x minus x1. The m is the 1/2, and then our point is going to tell me x1, y1. So in this case, x1 is 1, so it's x subtract 1. y1 is 3, so it's y subtract 3. That would be our equation. Nothing more to do with the equation. Now our domain, again, we go back to the left endpoint and the right endpoint. The left endpoint is above 1. The right endpoint is above, looks like 7. Since we're moving on the x-axis, we put an x in between. So our domain would be 1 is less than or equal to x is less than or equal to 7. That would be the two equations I need to see on the back of your paper for any and all slanted lines, using the appropriate slope and ordered pair. So remember, to do a slanted line, you need a slope and a point. Plug them into that equation. Well, as you're working your project, go through several times on this video, play it back and forth, see the information more than once. Good luck.